Hello, this is Jay Gandhi. I'm presenting Lab 1 of Physics 2. Intro. So the purpose of this lab was to find the excess charge on a piece of tape. So I used a GlowScript computational model, and then some physics principles I used were the force, was the electric field equation, electric force equation, and the gravitational force equation. So a brief preview. When the tape is rubbed against another piece, electrons transfer, creating a charge. If the objects repel, they have the same sign of charge. If they attract, they have different signs, or they're neutral. So to find the charge, we want to set the force of gravity equal to the force electric. We know they're equal because the change of momentum in the top piece of tape right here is going to be 0. And then you solve for charge, which is given in this work shown here. And then to find the electron deficit, you do Q over the fundamental charge. And then to find the atoms, we do the area of the tape, and then we divide that by the atomic length squared. So assumptions and reasoning. So we can set the two forces equal to each other because the momentum's not changing. Okay? And then some assumptions. We treat both pieces of tape as a single point, and then we assume both pieces of tape have the same charge, which isn't accurate, but we're going to assume that. And then we do this because we don't want to make the math too complicated, and it's easier to do this way. And then we'll still get an approximate charge, which is fairly close. So systems. The system is going to be the top tape, tape B, and the surroundings. The Earth causes a gravitational attraction on tape B, while tape A causes a repulsive force on tape B. So if we go back up here, so tape A causes electric force up, then gravity down. So initial conditions. I'm not going to go too much into detail on this. You can read through it. Experiment. Stick one piece of tape on the table, stick another piece of tape on the top of the first one to get tape A, and then repeat to get tape B, and then stick tape B between two walls to create a bridge-like scheme, like I showed you in the picture before, and then place tape A near B to create a repulsion, and then measure the distance between the centers. Alright, here's my code. So, I have my initial conditions, which were from lines 1 to 14. And then here's my function. And then so the main part is force of gravity, which is just the mass of the top tape times the acceleration of gravity. And then like I showed you in the work before, this is just the equation to get the charge. And then the E field, we use this function to get the E field. And then and then the force of electric is just going to be the E field times the charge. And then, so it's just an implementation of my calculations before. And this were the results. Yeah. So you can read through that. And then, so similarities and differences. So there were very few differences because this model was basically just calculations, not much coding really. And then, so it was based on the data I collected during the lab. So, some sources of error. So we obviously know that this is not the exact charge. One, because the distance between the tapes was not exact. Probably because human error. I got an inch, which is might be off a little bit. And then obviously the tapes don't have the exact same charge. And then the air transfers electrons to the tape in only a short amount of time. So what if and why? What if? So if the electrons had a positive charge and the protons negative, the tapes would have a net negative charge instead of a net positive charge, as the electrons still leave the tape. Alright? And the results would be the exact same because there's still repulsion. So why? The tape is positively charged in the experiment. This means that when you touch it, electrons leave your hand and stay on the tape. The charge, the magnitude of the charge decreases. And then that was my lab. Hope you enjoyed. See you later.